HCF and LCM by prime factorization. Dear students, let's learn how to find the HCF and LCM by prime factorization method. Here we are going to use the fundamental theorem of arithmetic, which states that any composite number can be expressed as the product of its prime factors. So let's take one example to find the HCF and LCM of two numbers. Suppose we have two numbers for which we have to find the HCF, and the numbers are 16 and 36. So we have to find HCF of 16, 36 and LCM of 16 and 36. So for that, first we'll have to do the prime factorization. We know how to do this. 16. Now 16 is even, so we can divide it with the first prime number, that is 2. So we get here 8, then again by 2, so we get here 4, then again by 2 we get here 2, and again by 2, so we get here 1. So this is the prime factorization of 16. Same way we will find for 36. 36 even number, so divide by 2, so we get here 18, again divide by 2, so we get here 9. Now 9 is an odd number, so we will divide it by 3, so we get here 3, and one more time by 3 we get here 1. Okay, now we can write this factorization as 16 is equals to 2 into 2 into 2 into 2, and 36 as 2 into 2 into 3 into 3. Now this can also be written as 2 raised to power 4, and here 2 raised to power 2 into 3 raised to power 2. Is it very clear? So in the powers we can write 16 as 2 raised to 4, and 36 can be written as 2 raised to 2 into 3 raised to 2. Now for finding the HCF and LCM, we need to govern two rules. That rule says HCF is the product of the smallest power of each common factor. So if you want to find the HCF, then we will look for the product of the smallest power of each common factor. So here this common factors is the important word, and if we have to find the LCM, then we go for the product of the greatest power of each prime factor. Now we can compare the two. Here we are looking for the smallest power, and here we are looking for the greatest power. Here we need to see the common factor, but here each prime factor. So common is not important for finding the LCM. So let's find out the HCF. So using this rule, HCF of 16, 36 will be product of the smallest power of each common factor. Now we can see common factor among these two factorization is 2, 2, because 3 is not appearing in the first factorization. So, and comparing the smallest is 2 raised to 2, so the HCF will be 2 raised to 2, that is 4. Is it very clear? Okay, so now we'll try to find the LCM of 16 and 36. Now for LCM, the rule says product of the greatest power of each prime factor. Now each prime factor means we will not go for common factors, and we have to go for the greatest power. Now 2 is there in both the factorization, and the greatest power is 2 raised to 4, so we'll have 2 raised to 4, and 3 is not there in 16 factorization, but it is there in 36 and its power is 2, so we'll consider that 3 raised to 2. So what we get here, 2 raised to 4 into 3 raised to 2, we get it as 144. So HCF of 16 and 36 is 4, whereas LCM of 16 and 36 is 144. Clear? We will see one more example to get the understanding in a proper way. Suppose we have two numbers, two 5 2 0 and 10530. We have to find the HCF and LCM of 2520 and 10530. So first, very quickly, we'll find the prime factorization. 2520 is even, so divide by 2. What we get here? We get here 1260. On dividing by, again as it is even, dividing by 2, we get here 630. It is again even, so divide by 2, so we get here 315. Now 315 is an odd number, but it is divisible by 3, so dividing by 3, we get here 105. 105 again can be divisible by 3, so dividing by 3, we get here 35. 35 is not divisible by 3, but we know it comes in the table of 5, so 5 sevens are, and 7 is the prime number, so dividing by 7. Clear? So same way we'll find out for 10530. It is an even number, so we get here dividing by 2, we get here 5265. 5265. Now 5265 is an odd number, but we know that it is divisible by 3, so dividing by 3, we get here 1755. 1755 again is divisible by 5. You know how to find the divisibility by 5? Divisible by 3, we just add the digits. 5 plus 5 10, 10 plus 7 17, 17 plus 1 18, and 8 plus 1 is 9, which comes in the table of 3, so it is divisible by 3. So we get here 585. Again we add the digits. 5 plus 8 13, 13 plus 5 18, 8 plus 1 9, so it is divisible by 3. 585 again it comes out 195. Again it is divisible by 3, so we get here 65. 65, you know, comes in table of 5, so 5 13s are, and we get here 13, as 13 is a prime number. Okay, now what comes next? We need to write its factorization properly. So we'll write here 2520 is equals to 2 into 2 into 2, okay, into 3 into 3 into 5 into 7. Same way for 10530, we can write it as 2 into 3 into 3 into 3 into 3, 1 2 3 4, and 5 into 13. Okay. Now if we write it properly, so we get here 2 raised to power 1 2 3 and 3 raised to power 2 and 5 raised to power 1 and 7 raised to power 1. Same way for here, 2 raised to power 1, 3 raised to power 1 2 3 4, 3 raised to power 4 into 5 raised to power 1 into 13 raised to power 1. Now we know how to find the HCF. HCF of 2520 and 10530 is, what is HCF? Product of the smallest power of each common factor. So common factor we'll have to see. 2 is common, and smallest is 2 raised to 1. 3 is common and smallest is 3 raised to 2. 5 is common and smallest is 5 raised to 1. Same way, LCM of 2520 and 10530 will be, what is the rule? Product of the greatest power of each prime factor. Now 2 is common and greatest is 2 raised to 3. 3 is common and the greatest is 3 raised to 4. 5 is common, greatest is 5 raised to 1. 7 is common, no, it is not common, but we are not considering the common, so 7 raised to 1 and 13 raised to 1. All the factors with their greatest power we have considered. Now for HCF, it is easy. 5 2s are 10 and 10 3 square is 9, so 90. 90 will be the HCF. But what will be the LCM? It is going to be a big number. Okay, it is going to be a big number. And what is that number? The LCM of these two, you can see 2 raised to 3, then we have 3 raised to power, 4, okay, then 5, then 7, and then 13. It comes out to be 294840. 294840. You can check this. Okay, so hope this HCF and LCM by prime factorization is clear to you, and more important are the rules which we are going to follow. HCF says product of the smallest power of each common factor, and LCM says product of the greatest power of each prime factor. Okay, take care.